All right, guys, this is the review for the 9798 quiz. And if you understand everything in this review, the quiz follows very closely to this. So, first thing that you're going to have to do is list the first four non zero terms and the general term for the Maclaurin series for these four functions. And I will probably mix up the order on the quiz. So don't expect it to be sine, then cosine, then e, then this geometric one. So make sure that you can list those. I'm going to do that on a separate sheet of paper. So if you have not practiced this, it really just takes like writing it down a few times to remember these, I found. So sine x is the one with all of the odd exponents. So it starts with x to the first minus x to the third over 3 factorial plus x to the fifth over 5 factorial minus x to the seventh over 7 factorial plus dot 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 plus. The nth term is negative 1 to the n because this is assuming we're talking about n equals 0, n equals 1, n equals 2. So negative 1 to the n, x to the 2n plus 1, so that makes this, 2 times 3 plus 1 is 7. And it's over 2n plus 1 factorial. Make sure you put a plus dot 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 after the nth term because the Maclaurin series does have infinitely many terms. Cosine x has all of the even exponents. And remember, that means x to the 0 is even. So that means that your first term is constant. And then it's minus x squared over 2 factorial plus x to the fourth over 4 factorial minus x to the sixth over 6 factorial plus dot 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 plus negative 1 to the n, because again, when you put in n equals 0, you get positive 1. X to the 2n over 2n factorial plus dot dot dot. E to the x is not alternating, and it is just 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot 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 plus. There's no negative 1 to the n here. It's just x to the n over n factorial plus dot dot dot. And our final one is this is the sum of a geometric series where r is x and the first term is 1. So this one is just 1 plus x squared, so no factorials, plus x cubed plus dot 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 plus x to the n plus dot dot dot. Because remember, like I'm saying, that one, you don't have to write this down, but that one is a geometric series where you start at 0, you go to infinity, and it's just x to the n. So the a0 term is 1, and then every term after that, the common ratio here is x if you divide consecutive terms. All right, so make sure that you know those four. Practice writing them a few times. You don't have to label the n's up here for me, but those are the n's that I'm expecting us to use to match up these exponents. All right, so what else do we have to do? Know the formula to find Lagrange remainder, alternating series remainder, and actual error. So here's the Lagrange formula. So we're saying, in general, if I want to know the difference between f of x and some nth degree Taylor polynomial for x, that's equal to the remainder at x. For Lagrange, that's less than or equal to the n plus 1 derivative evaluated at z. This will be some max value you have to figure out, times x minus c to the n plus 1 over n plus 1 factorial. The alternating series remainder says the difference between f of x and some Taylor polynomial of a certain order is also equal to a remainder of that order at x, and that's less than or equal to the n plus 1 term in absolute value. Remember, the n plus 1 term, if that's a 0 term, it's the first neglected non-zero term. So if we're using sine or cosine, for sine, it's going to be the next odd term, and for cosine, the next even term. Actual error is when you are just actually typing in f of x minus whatever your approximation is and getting an answer. We usually have an error bound because the whole point is that we can't find the actual value. But if I say, okay, go ahead and find cosine of 0.1 in your calculator and compare it to what your third order Taylor polynomial says, then you would just subtract those and give me the actual error. Know how to build a Taylor series centered at C for any function. So this is where we're saying, okay, some Taylor series p sub n of x, it's equal to f of c plus f prime of c times x minus c to the first over 1 factorial plus f double prime at c times x minus c squared over 2 factorial plus f triple prime at c times x minus c cubed over 3 factorial, and you could carry this out for as many terms as you need to. So know how to do that. Know how to approximate a function using Taylor polynomial. So you just plug in whatever the value is into that thing. Make sure you've practiced that on your calculator. It does take a bit of typing, but you just have to kind of carefully do it. And then know how to find the Lagrange error bound and what value of n is needed to achieve desired accuracy. So this is where we plug in n plus 1 and use our calculator. So you will be allowed to use a calc. All right, so let's look at some examples. Like I said, I have the same types of questions on the quiz. So as long as you've done this review and you've been doing the homework and you've come into office hours to get whatever questions answered you have on this, you should be in pretty good shape for the quiz. All right, so this says write a fourth order Taylor polynomial for f of x equals sine x centered at c equals pi over 3. So we can't just use our shortcut and build this like we talked about at the end of the notes because it's not a Maclaurin polynomial. So we're going to have to do this the long way, and then we will use that Taylor polynomial to approximate sine of 2 pi over 9. So remember, first we need to build this. So I'm not going to rewrite the formula, but I'm using this formula right here. I need to evaluate f of c, f prime of c, f double prime of c, all the way out to the fourth order. So f of x is sine x. So f of pi over 3, think about your unit circle, that is radical 3 over 2. And then we need to take 4 derivatives. So f prime of x is going to be cosine x. F prime of pi over 3 is equal to 1/2. F double prime of x is negative sine x. F double prime of pi over 3 will be negative radical 3 over 2. F triple prime of x is negative cosine of x. F triple prime at pi over 3 is negative 1/2. And the fourth derivative of x gets us back to sine x. For sine and cosine, it takes 4 derivatives. The fourth derivative will get you back to the original function. The fourth derivative evaluated at pi over 3 is radical 3 over 2. Okay, so now let's write out what our fourth order Taylor polynomial is. So we're saying sine x can be approximated by f of pi over 3, so radical 3 over 2, plus f prime of radical 3, so 1/2 times x minus pi over 3. You don't have to simplify this at all, so just keep going. So then minus radical 3 over 2 times x minus pi over 3 squared over 2 factorial. So I just did this term, and the f double prime of c was this fraction. Now I'm on the third term, so minus, I'm going to leave the 1 in there, 1/2 x minus pi over 3 cubed over 3 factorial. We're going out to a fourth order, so plus radical 3 over 2 times x minus pi over 3 to the fourth over 4 factorial. So this is the first part, right? The fourth order Taylor polynomial, done. We did that. And then approximate sine of 2 pi over 9. So I have to type 2 pi over 9 into this, or if you want a little less typing, what is 2 pi over 9 minus pi over 3? So pi over 3 is 3 pi over 9. So it's negative pi over 9. I want to save myself a little bit of typing. So I'm going to, anywhere I see parentheses, I've already done the subtraction. I'm going to type in negative pi over 9. And again, take your time on this. It's not a long quiz, so you've got time to type this in correctly. And you can use the fraction key if you want to. So radical 3 over 2. And then it's plus, I'm not going to type in the 1, but I said this was negative pi over 9 divided by 2. I think I'm going to use the fraction key for the rest of this. So minus alpha y equals gets you to fraction. All right, so this is radical 3 times negative pi over 9 to the second power over 2 times 2 factorial. Now I'm just going to do the math down there. 2 times 2 factorial is 4. And then it's minus alpha y equals this fraction. Negative pi over 9 to the third power over 2 times 3 factorial. So 3 factorial is 6. 2 times 6 is 12. And then it's plus alpha y equals gets me the fraction. Radical 3 times negative pi over 9 to, whoa, wait a minute. Okay, hold on. Weird things are happening here. I must have hit an exponent key somewhere. Okay, negative pi over 9 to the fourth over 4 factorial is 4 times 3 times 2, so that's 24. 24 times 2 is 48. If you don't trust your math, then you're in the fraction key anyway. You can type in 2 times 4 factorial. Remember, factorial is alpha window, if you need it, down there. All right, so let's see. I'm getting 0.642 ... I'm just verifying on my printed out key that that's what I got, and I did. So include all of the decimal points, please, so we can see how accurate we are. 0.642 811,312. All right, so that's my approximation, and I think I'll box in my other answer for the Taylor polynomial itself. Fix this because it's bothering me. Okay. All right, so what else do we need to do? We just approximated something, so how good is that approximation? Find the Lagrange error bound for the approximation. So we used a fourth order. So this is asking me, okay, there's an actual sign of 2 pi over 9 value. The difference between that and your fourth order Taylor polynomial approximated at 2 pi over 9, what is that equal to? That's equal to the remainder, the fourth order, at 2 pi over 9. By the way, I'm writing all of this out. This is not required, but you're going to see this notation on the AP test, so I just want you to be familiar with it. Okay, and that is less than or equal to, now we have an n here, so make this the fifth derivative at some z value. It's going to be a maximum that we find, times x minus c, so 2 pi over 9 minus c, which is pi over 3, to the fifth, over 5 factorial. We're not given a value that this is supposed to be less than because we are finding what this error is. Now remember, f of x, if f of x is just sine x or cosine x, not 2x or 3x or any of that, if that's sine x, then f of 5z, its maximum is going to be 1. We might not actually hit 1. It'll be a cosine curve, and if you're just between pi over 3 and 2 pi over 9, you might not actually hit 1, but we're just overshooting here and going for maximum possible error. So now I know that this is 1. I already did the subtraction on this. Remember, this was negative pi over 9, but let's just make it pi over 9 positive, because when we raise it to the fifth, we want this to stay positive. And 5 factorial, I know that one's 120. So just to save myself some typing there, I can do that. And let's go ahead and find this value. So the remainder, our error bound, for our approximation is pi over 9 to the 5th power. Divide that by 5 factorial, which is 120. So let's write this out. If this is times times 10 to the negative 5th, that means you put 4 zeros in front. 1, 2, 3, 4, and then you get to write out the rest of the numbers. So 4, 3, 1, 8, 7, 2, 5, 1, 9, 4. The important piece of this is that the number of zeros is how accurate, how many decimal places you're accurate to. It means that my approximation and the actual sign of 2 pi over 9 should match for the first 4 places where these are zeros, and then they're going to be off. All right. What about the next question? So the next question says, this was the answer to this one. Next question says, determine how many terms would be necessary so that this difference, this error bound, is less than 0.0001. So let's assume it's still talking about Lagrange. All right, so that just changes this to saying, all right, and this should be not P4. This should say P N. Okay, so what do we do for this? So we're saying we're trying to find some sort of remainder for some degree polynomial. We don't know the degree or the order. When we evaluate at 2 pi over 9, we know that that should be less than or equal to the n plus 1 term at z times 2 pi over 9 minus pi over 3 to the n plus 1 power over n plus 1 factorial. And we're trying to keep this less than 0.0001. Now, like we said before, remember, it doesn't really matter what number derivative you're on. If you're talking about f of x being just plain sine x or cosine x, then the max value is equal to 1. So I can replace that with a 1. We've done the subtraction on this before. It's negative pi over 9, but let's just make it pi over 9 to the n plus 1, and this is over n plus 1 factorial. Now I'm going to go over to my calculator at this point. You can multiply this around if you want to, but I think it's just as easy to go to the y equals in your calculator, type in pi over 9, raise it to the x plus 1, and then divide that by x plus 1 factorial, so alpha window factorial. And then go to your table. My table is starting at 0. If yours is starting at a crazy place, like from our last test, if it's in the thousands, go to second window and tell it to start at 0, and then second table. Anyway, and then be over here so you can really see what the decimals are. So we need 0.000. So that's not it. That's not it. That's not it. Here's 0.0006, but we want less than 0.0001. So let's keep going. So the next one is 0.00. Where am I? 0.00. Oh, this has. Wait, I went too far. Sorry. Here, this has 4 zeros in front and then 4, 3. So it should be n equals 4, right? Now, I have n equals 3 on my paper, so I'm trying to look at that. Did I type this in correctly? Pi over 9 to the x plus 1. I think this is right. So I'm getting, I'm not getting 3. That's 0.0006. I don't think that's going to work. If we want to double check this, if we did flip this around, we'd be comparing to 1 over 10,000. We'd be comparing to 10,000. But yeah, I think I'm going to go with n equals 4 for this one. All right, so I'll just probably have to adjust my key. So I'm getting n equals 4 because that gives me something less than 0.0001. So I think that's okay. And let's see. Do we have to approximate? No, just determine how many terms. Now this is n equals 4. How many terms is that? Let's be careful with this. This is a sine function. So think about the sine Taylor polynomial here. We have degree 4. Oh yeah, okay. So this one doesn't have any 0 terms. So yes, the fourth order does go with the fourth degree. So I was looking back up from part A. I was thinking if we had any 0 terms, we'd have to see if 4 is one of the 0 terms or not. But n equals 4. So this is, how many terms is that? 1, 2, 3, 4, 5 terms. Fourth order, 5 terms. Because you have the constant plus 4 terms. All right, so if you're ever not sure on that, if you haven't written it out for a previous part, write out what the fourth order polynomial would be and then just count the terms. All right, now find the actual error between your approximation and the sine of 2 pi over 9. So let's see, do I still have this on here somewhere? If I press second enter, it'll recall the last line that I typed. Let's see. I'm trying to do second enter, second enter, second enter, second enter. I've done this 3 times now, so it's, there we go. Okay, here is that approximation value. What's the difference between that and the sine of 2 pi over 9? So I'm in radian mode. I'm going to type in sine of 2 pi over 9. Oh my gosh, I'm having typing issues today. Okay, 2 pi over 9. This is the quote-unquote actual value. That answer minus my approximation comes out to negative, split screen here, 0.12342370023. Okay, that's pretty good. Let's take a look at the next page. Calculator allowed. So it's been allowed this whole time. That's okay. So find the interval of convergence for each power series. Be sure to show both series you check to check the endpoints. So I am giving you multiple points for a problem like this. You do need to have the correct work as if this were a free response question. So we should start with the ratio test. The limit as n approaches infinity of the absolute value of x plus 2 to the n plus 1 over 3 times n plus 1, or you can make that 3n plus 3, times 3n over x plus 2 to the n. So what will we have left here? So the x plus 2 and the x plus 2 to the n is going to cancel out. You'll be left with x plus 2 to the first. So you've got 3n times x plus 2. It doesn't matter to me if you rewrite this, by the way. I'm just trying to be clear on my answer key. Over 3 times n plus 1. So the 3n over 3n plus 3 is going to approach 1. So you essentially have 1 times x plus 2 if you do that limit. So this comes out to the absolute value of x plus 2. And this converges by the ratio test if the absolute value of x plus 2 can stay between, well, x plus 2 can stay between negative 1 and 1. This is the ratio. The radius of convergence, by the way, is 1. Solve this by subtracting 2. So you get negative 3 is less than x is less than negative 1. Now you need to check the endpoints to see if we should be including either of those. That just means that sometimes when you plug in these endpoints, you get a series that's alternating or something like that. All right, so next step is to check the series. So what I mean by be sure to show both series you use to check the endpoints, that's this part. So let's say x equals negative 3. Show with all the nice labels and everything what that comes out to. So negative 1 to the n times negative 1 to the n over 3n. Now simplify that, or at least, well, no, yeah, simplify that. Now this is negative 1 to the 2n, and that's always positive 1. So I'm just going to write 1 over 3n. And this series diverges because it's the harmonic series. If you need more room to do this on the quiz, you can just use extra paper. So we're not including that endpoint. Check x equals negative 1. So that makes it the series from 1 to infinity of negative 1 to the n. And then when you plug in negative 1 here, you're going to get 1 to the n. So that can just go away. That's just times 1, and it's over 3n. Now this is an alternating series. The terms for 1 over 3n are approaching 0. So this converges by the alternating series test. So my final interval of convergence is not including negative 3, but I am including negative 1. Remember, what this means is whatever f of x this matches up to, f of x matches exactly the sum of this infinite power series if we're plugging in numbers between negative 1 and negative 3. All right, for the next one, same thing. I've got to do ratio test. The limit as n approaches infinity of x to the, it'll be 2n plus 2, because you're plugging into 2 times n plus 1, over n plus 1 factorial times n factorial over x to the 2n. So the x to the 2n will cancel with x to the 2n plus 2 and leave you with x squared. N plus 1 factorial is n plus 1 times n factorial. So the n factorials can cancel. So I'm just going to rewrite this just so it's clear for the key. So now I have the limit as n approaches infinity of the absolute value of x squared over n plus 1. As n approaches infinity, this becomes 0 times x squared. So that's just coming out to 0. 0 is always less than 1. So this series converges by the ratio test for all x. That means that the interval of convergence is negative infinity to infinity, and we don't have to check endpoints because they're not numerical, they're just directions. All right, for my next one, I'm going to use ratio test again. The limit as n approaches infinity of x minus 1 to the, so this will be 2 times n plus 1 plus 1. 2n plus 2 plus 1 is 2n plus 3. And this is 2n minus 1, so 2 times n plus 1 minus 1. 2n plus 2 minus 1 is 2n plus 1. Plus 2 minus 1, yeah. And then this is 2n minus 1 over x minus 1 to the 2n plus 1. The x minus 1s will cancel, and the difference between 3 and 1 is 2. So you're going to be left with x minus 1 squared. So I've got the limit as n approaches infinity of x minus 1 squared times 2n minus 1 over 2n plus 1. As n approaches infinity, 2n minus 1 over 2n plus 1 approaches 1. So this is like having x minus 1 squared times 1. So we get x minus 1 squared. Now that needs to remain less than 1 in absolute value. Just square root right away though. If x minus 1 squared needs to stay less than 1, you can square root both sides right here and say that means x minus 1 in absolute value needs to be less than 1. You don't need like a weird plus or minus. Don't overthink this. We're just saying this will converge. Let me do this over here. This series converges just like we do for any other one by ratio test. If negative 1 is less than x minus 1, which is less than 1. And then I'm going to add 1, so I get 0 is less than x is less than 2. And I need to check the endpoints on this. All right, so start with x equals 0. That makes this the sum from 1 to infinity of negative 1 to the n. Put a 0 in, you get negative 1 to the 2n plus 1 over 2n minus 1. Now add these exponents together because you have the same base. So n plus 2n is 3n plus 1. the question is 3n plus 1. Is that going to give you odds and then evens and then odds? So just start plugging numbers into it. If you plug in 1, you get 4. If you plug in 2, so 4 is even. If you plug in 2, you get 7. That's odd. If you plug in 3, you get 10. That's even. So yeah, this is alternating. Then I might as well just make it negative 1 to the n or whatever. It's alternating. You can leave it 3n plus 1 if you want, but I just like to make a note to myself that's alternating over 2n minus 1. Because if I just make it negative 1 to the n, that's going to give me the same plus and minus signs that I had before. Or maybe I should just do, I guess it'd be n plus 1. Whatever. I can leave it like that. I can leave it 3n plus 1 or n plus 1. I guess n would have given me the wrong plus and minus signs in the wrong order. But the whole point is this converges by the alternating series test. Okay, so we are going to include 0. And then what about x equals 2? That gives us the sum from 1 to infinity of negative 1 to the n. If you plug 2 into this, 2 minus 1 is just 1 to the 2n plus 1. But that can go away. That's just 1 over 2n minus 1. This is also an alternating series, so it converges by alternating series test. So for this one, we include both endpoints. 0 is less than or equal to x, which is less than or equal to 2. So this series has a sum for any x between 0 and 2, including both of those endpoints. All right, so where did I just go with that? So there we go. Given this power series, find the series and intervals of convergence for each of the following. So find f prime x and find the integral of f of x dx. You don't have to expand out terms for this. When I say find f prime, I just mean go ahead and write the power series. Remember, you might need to make an adjustment here, so keep this blank until you're done. Take the derivative of this term. So this would be 2 times n times x plus 2 to the n minus 1 over n factorial. All right, now here's where you might want to list out some terms, right? So first of all, this n and this n factorial can cancel to just n minus 1 factorial. All right, so what should the terms be? You don't have to list out terms if you don't want to, but if you're going to list out terms, I would list out terms for this one first. So like if I put in 0, I get 2. And then if I put in 1, I get 2 times x plus 2. If I put in 2, I get 2 times x plus 2 squared over 2 factorial. Maybe I'll put in one more. 2 times x plus 2 cubed over 3 factorial. So the point is you might do this to say, okay, what do I do if I get derivatives of this? So that would go away. This would just be 2. The first term should just be 2. That means that I should start at 1. I can't start at 0 because that'll give me an x plus 2 to the negative 1. So that's no good. And we don't have negative factorials. So 0 should be the first term. I should get 2 for the first term. And then if I plug in 2, I get 2 times x plus 2 to the first over 1 factorial. And yeah, this is going to give me 2 times x plus 2 to the first if I take its derivative. So you don't have to do the terms, but you can. Let me clean that up a bit. It's a series from 1 to infinity of just 2 times x plus 2 to the n minus 1 over n minus 1 factorial. What about the interval of convergence? So you can do the interval of convergence on f of x. It might be faster to do that than this one. I don't think it really matters, but and then remember, it should be the same for both of these. You're just checking endpoints. So for f, I'd be doing the limit as n approaches infinity of the absolute value of 2 times x plus 2 to the n plus 1 over n plus 1 factorial times n factorial over 2 times x plus 2 to the n. So x plus 2's cancel, leave you with an x plus 2 to the first. 2's can cancel. N factorial can cancel with n plus 1 factorial. It just leaves you with n plus 1. So all you have here is an x plus 2 over an n plus 1. So actually, this interval of convergence, this is always nice. Interval of convergence, because this limit is 0, will be negative infinity to infinity. So what's the interval of convergence for f prime? Well, it's the same as the interval of convergence for f. The only thing that could change are the endpoints, but they can't change if they're plus or minus infinity. When we say the endpoints could change, we mean that if they're numbers, you could exclude them or include them depending on what you've done with the calculus. So same thing on this one. Let's find the series. So remember, you're going from f of x here. So what do you do in this case? It'll be the sum from n equals something to infinity. The 2 is there. The x plus 2 becomes to the n plus 1. There's already an n factorial down there, but you also multiply by the new exponent. Now, n plus 1 times n factorial is n plus 1 factorial. And let's see, what should the terms be? So the first term should be 2 times x plus 2. So if we put in a 0 here, that should make that happen. 2 times x plus 2 to the first over 0 factorial times 1 factorial. Those are both equal to 1. So yeah, that's right. I'm just going to clean this up a little bit. I don't think you would get counted off if you don't simplify that expression, so you don't have to, but it is a good thing to be able to do, I think. And then again, my interval of convergence is still just all real numbers. All right, so these are all the same types of questions that you have on your quiz. So I think it's the same length. I've got space for you to write these 4 series to make sure you've studied those. That should be easy points. Yeah, please come into office hours if you have any questions.